Before we define what discrete random variables are, let's first understand the difference between discrete and continuous functions. A discrete function is a function that takes on a countable number of values. For example, consider the function that represents the number of students in a math classroom over different years. The number of students can only take on integer values, so this function is discrete. If we had to plot this function, we would see a series of points on a graph like this. As you can see from the graph, the number of students in the classroom only takes on integer values and does not change continuously over time. That is, there is nothing between two consecutive points on the graph. This is what we mean by a discrete function. On the other hand, a continuous function is a function that can take on any value within a given range. For example, consider the function that represents the height of a tree over time. The height of the tree can take on any value, not just integer values. If we had to plot this function, we would see a smooth curve on the graph like this. From the graph, we can see that the height of the tree can take on any value within the given range and changes continuously over time. That is, there are infinitely many points between any 2 points on the graph. This is what we mean by a continuous function. Now that we understand the difference between discrete and continuous functions, let's define what a discrete random variable is. In our previous video, we defined random variable x as a function from S to real numbers, where S is the sample space and R is the set of real numbers. We then also looked at an example of a random variable x that counts the number of heads when flipping a coin twice. The sample space S for this random variable is the set of all possible outcomes when flipping a coin twice. And the output of the random variable x is the set of real numbers, which in this case is the set of all possible number of heads we can get when flipping a coin twice. This random variable x is actually a discrete random variable. A discrete random variable is a random variable that can take on a countable number of values. In other words, the sample space and the output of the random variable are both countable sets. Since they are countable, we can list all the possible values that the random variable can take on. And this is what makes it discrete. In this particular case, there is no way to get 1.5 heads when flipping a coin twice. The number of heads can only be 0, 1 or 2. Next, let's move on to the probability mass function of a discrete random variable. The probability mass function of a discrete random variable x is a function that gives the probability that a discrete random variable is exactly equal to a certain value. Mathematically, the probability mass function of a discrete random variable x is defined as follows. Here, x equals x sub I means that random variable x returned the value x sub I. Capital P denotes the probability function, and p sub I is the probability that random variable x is equal to x sub I. Let's understand this definition using our running example of the random variable x that counts the number of heads when flipping a coin twice. Let's say we want to find the probability that random variable x will return 0 heads after flipping the coin twice. Using the naive definition of probability, we can say that the probability of getting 0 heads is the number of ways we can get 0 heads divided by the total number of outcomes. In this case, the number of ways we can get 0 heads is 1, and the total number of outcomes is 4. Therefore, the probability of getting 0 heads is 1 divided by 4. Similarly, we can find the probability of getting 1 head and getting 2 heads. We can also plot the probability mass function of a discrete random variable on a graph. The x-axis represents the possible values that the random variable can take on, and the y-axis represents the probability that the random variable is equal to that value. This graph depicts the probability distribution of the random variable x that counts the number of heads when flipping a coin twice. Each dot on the graph represents the probability that the random variable x is equal to a certain value. Since each dot represents a probability, the sum of all the probabilities must be equal to 1. After plugging in the probabilities values, we found that this is indeed the case for our example. That's it for this video. Today we learned about discrete random variables and the probability mass function of a discrete random variable. Then we also saw what a probability distribution looks like on a graph. In the next video, we will look at different types of probability distributions such as the binomial distribution. Thank you for watching.